Let's see who of you is really excited about code quality. Nice. And I'm really curious, how many of you guys are happy and satisfied with code quality on your current project? Please raise your hand to let me know. Not so many people. And who has more than 5 Flutter developers working on the same code base, in the same repository? All right, more people. Well, the good news is that my goal for today is to empower all of you with guidelines and tools so that you can set the code quality bar to a higher level and keep it there with less manual effort. Before I dive into the topic itself, I would like to give you a bit more context about myself. My name is Pavel. I'm a lead software engineer at the company called EPAM. I touched Flutter the first time in 2018, loved it, and in 2020 I switched to full-time Flutter development. I maintain a technical blog that you are very welcome to check out. And also here today, I'm representing our awesome Flutter Netherlands community. Dutch, you guys, make some noise. Right. Well, let's get started. First things first, setting up continuous integration, continuous delivery, and deployment is a must. So if you don't have it still on your project, make sure you do as soon as possible. And if you do, let's see how you can enhance your CI flow to make it even more robust. The code quality gates that you are about to see are divided into 3 categories. I divided them so based on the amount of effort it takes to set them up. So start with the basic ones first. And the first one on the list is code formatting. Luckily, Dart tooling has an option out of the box to support us, to validate it, so do use it. But do not limit yourself to Dart files only. Look for more opportunities. For instance, if you use Node Package Manager plus the tool called Flutter, then you can easily enforce formatting of your JSON, JavaScript, YAML, Markdown, and other types of files. Similar advice applies to spelling. Everyone makes mistakes, including typos, so check out the popular tool called cspell. I have seen it used on a number of open source projects. In addition to that, make sure you install a plugin into your IDE, and then you're good to go. When it comes to the topic of static code analysis in Flutter, you should know the following. That's good that the Flutter lints package is already integrated into the default Flutter application, but that is not enough. What I advise is to make sure that you fail your CI pipeline, not only on the presence of errors, but also on the presence of warnings and infos. Also make sure you enable strict type checks and look for more lints. As you might have already guessed, Flutter lints is covering only a subset of lints available from Dart SDK. You should pay a closer attention to somewhere here. It covers less than a half. It's only 46%. So if you, for instance, use the very good analysis package, then your code base will be in almost twice as good shape. Taking a step further would involve the integration of additional lints developed by the community. Dart code metrics has been around for quite some time. It was introduced in 2020. Our teams have been using it for years. And even though it was discontinued the last year in favor of DCM, it is still possible to use the old and free version. If you want to go even further into this topic, then the next level for you would be to involve the package called custom lint. With this library, you can develop lints tailored to the specific needs of your team and your project. So do try it out. Another wonderful tool that I discovered only recently, a few months ago, is called Pyramid Lint. It is based on top of the custom lint, and it provides you more than 40 rules out of the box. Some of those rules you see on the slide. For instance, you can easily make sure that your controllers and other resources are properly disposed, or that you don't have any mutable global variables, which is not recommended, of course. Really, really cool stuff. When you're confident about your linter setup, the next step you would want to think about is your architecture. Every serious application uses some sort of architecture, having some layers and following some rules. What I highly recommend to you here is to prefer physical separation over logical. What do I mean by that is that you'd better create Flutter and Dart packages instead of having just the application package and having bare folders. For the sake of conveying the idea, in one of my articles, I took the default Flutter account application and got it refactored in a modularized solution with the following 5 modules. If you're familiar with domain-driven design or clean architecture, then those names should be known to you already. Nothing fancy or extraordinary here. What are the advantages, you may ask? Well, first of all, you have stricter visibility control. You can enforce or have package-level encapsulation, and compiler and analyzer are playing on your side here. Second of all, you can benefit from high reusability potential when you can take a package and use it inside another application. And the third benefit is that you can have incremental builds and CI optimizations. A solution like this, when you have multiple packages in the same repository, is called a mono repository. And when it comes to mono repositories, there is one tool you should be definitely familiar with. The tool is called Malus. It helps a lot, really a lot, in managing a mono repo. You can easily execute all your scripts across all your packages or only across a subset of packages based on keywords. You can also update your external dependencies in one file instead of doing it in every PubSpec YAML file of every package. Really, really handy. So I can recommend this tool without any doubt. The one thing, though, which surprised me when I discovered it 4 years ago is the fact that Dart compiler has no problems with cyclic dependencies inside your mono repo. It can compile that. It has no problems with that, but I do. I don't think this is a nice way to do things. That's why I recommend to you to check out this Malus option, which you can easily spot those things for you. And if you're doing good, if you don't have any cyclic dependencies between your packages, then you will see this positive message. That means that this is easily automatable and can be put inside your CI pipeline as well. And I definitely recommend doing so. And the one more thing I especially love about this command there is blazingly fast. It gives the results in less than a second, no matter how many packages you have, even if you have 100 packages inside your mono repo. The next thing is to be careful about your external dependencies. All Flutter applications rely on some packages and plugins from PubDev, and dependency validator can make sure that you have no misused, like missing, under-promoted, or promoted, or unused dependencies. So integrate it in your CI pipeline as well, and you're good. You're good to go. Let's move on. I bet we all sometimes just copy and paste some pieces of code instead of doing the proper refactoring right away. This may be good when you're doing some proof of concept, but in the long run, this is not a maintainable approach. This tool can easily spotlight those issues. It is configurable, meaning that you can adjust its strictness. And so don't accumulate technical debt. You can adjust the strictness, you can exclude certain files like generated ones or tests. Who here has any tests on the Flutter projects? Okay, some people, I would say maybe 30%. Well, when it comes to the topic of automated testing, there is one key concept you should be aware of. This is the testing pyramid. A few things to remember here. First of all, you would better write tests of different granularity or of different type. And the higher you get to the top of the pyramid, the fewer tests you should write. Why? Because they're more expensive. They're more expensive from both maintenance side and from the execution resources side. So be aware of that. Let's briefly touch each of those types. When it comes to the topic of unit testing, what I advise is to test the behavior of your units, of your classes, and not the implementation detail. Read upon the difference between fakes and mocks. And make sure you also know the difference between white box testing and black box testing. One of the advantages of unit testing, one of the implicit advantages, is that you inevitably have a better architecture. Because in order to make your classes unit testable, you have to properly either write them the good way from the start or do the factoring, so you avoid static cleans and other unrecommended approaches. Also, make sure you know first and arrange assert principles. And the tools which prove to be quite helpful are Clock, Take-Async, Mocktail, or Mockito, if you prefer the latter one, and Parameterize Test. Okay, now I would like to move to the topic of widget testing. Be aware that you can not only test the behavior of your widgets, like tapping a button and verifying a change of the state, but also you can test the accessibility of your widgets. More and more companies nowadays try to make their applications accessible to everyone, including impaired people, so this topic may be also important in your circumstances. A special subset of widget testing is called golden testing or snapshot testing. We do love them. We do use them a lot in our projects. If you're not aware, basically an image of your widget is taken and put into a file. And the next time you run the test, a new image is created in memory and compared pixel by pixel with the image from the file. And if there is a small pixel difference, then such a test fails. Really useful. You can validate your UI layout, theming, different sizing on different screens. One of the ways to motivate, or let's say enforce developers to write tests is to verify the code coverage. My advice here is to be reasonable about the threshold value. Trying to achieve 100% code coverage is not always reasonable. What you can also do, if you have a multi-modular solution, like I recommend, you can set different thresholds for different packages. For instance, for a package with your business logic, like the main, you can set a higher threshold, let's say 80%, and for a package like data, you may set 50%, just as an example. Well, when it comes to the topic of end-to-end integration testing, which is usually a less used option, especially on small or startup-like applications, I can recommend trying them out. You may get a good return on investment if you do it the right way. And choosing the right testing tool, environment, and approach is something of vital importance here. Sync up with your QAs, sync up with your automation QAs if you happen to have those guys on your project, and it should be good to give it a start. And to give you some brief overview, these are the popular tools which are able to cover Flutter applications. On one side, there are mature tools like Appium and WebDriver.io, which have been there on the market for about a decade. On the other side, there are some newer players like Patrol or Maestro, which are quite promising and which even may surprise you. To give you the notion how easy it can be, I decided to write an end-to-end integration test for one of my web applications, which I released about 5 years ago. I decided to wipe the dust from this app and roll this test with Maestro. It literally took me about 20 minutes to install the tool itself on my machine, to play a bit with Maestro Studio, which is a UI inspector, where I could see all the UI elements of my application, and complete this test in YAML format. The source code of the test you are just seeing on the screen. I didn't have to install any dependencies or do any weird configurations inside the application itself, which was really, really cool. That means that with the right tool, the process can be really fast and really easy and enjoyable. A really outstanding type of testing that you may never heard of is called architecture testing. I really love it. This is one of my favorite topics. And your goal here is to automate the architecture rules that you have on your project. Get some inspiration from the tool called ArcUnit. This is the tool that exists in .NET and Java worlds. Unfortunately, not in Dart and Flutter, but still, you can get inspired. You can use simpler tools just to come up with some automated tests and to give you some inspiration and some idea. This is one of the architecture tests from a previous project. We had a feature-oriented architecture, and one of our architecture rules was that our features should not have dependencies on each other, because we didn't want to have tight coupling between the features. And with the help of this quite naive but quite small test, we could achieve the automation of this rule. It was really powerful and really saved us quite some time during our pull requests. Reviews, I mean. Well, it was quick, and having gone through all of these checks, CI checks, you may be wondering, how much time would it take to run all of them on a project of a big or even huge size? Well, of course, the universal answer depends. But what I can recommend is to look for some optimizations. Obviously, you can run things in parallel. But besides that, what you can also do is to be selective. Selective what you check at your PRs in your CI pipeline. What do I mean by that? Let's say you make a change in one of your PRs only on the presentation layer. Like you are creating a new page, updating a widget, or changing an existing page. Then it doesn't make any sense to run all of your CI checks on the main package or on data package, because they have no dependencies. You're just wasting your resources. What makes sense to check is only the presentation package itself and the one which depends on it, the application one. Luckily, the Melos tool has also an option here to help us out with that. With this option, you are able to identify a list of packages which has been changed in the current Git branch. Under the hood, Melos uses Git diff functionality to achieve that. And you can use this list of packages as a filter for all your CI commands. So, save your time, save your money by checking only what is really needed. Overall, the more validations you can automate and put inside your CI pipeline, the easier it is for you when you are doing your pull request reviews. Then you can spend your precious time on checking some other more important things like business logic and behavior. So set stricter policies for your pull requests, be consistent, and automate as much as possible. Hopefully, you got some food for thought, and I would love to wrap it up with the following idea. Some people say that knowledge is power. That's true, but that is true only to some extent. The real power comes when you apply the knowledge, when you use it, when you put it in practice. So, don't postpone until tomorrow what you can do today. Make your CI pipeline more robust so that the next time I see all of you guys and ask a simple question, how satisfied are you with the code quality on your current project? The next time I do it, I hope to see way more raised hands. Well, that's about it for today. This is the QR code to my blog, where there are a bunch of articles covering these topics in way more details, along with code samples and GitHub repositories. I'm quite sure you will have something to learn from it. Check it out. That's it for today. Cheers. I'll see you some other time.